Namaskar friends, I welcome you all in this class of mathematics. So, you must be remembering in last classes we have been discussing limits of a function. Now, today we are going to discuss the continuity of a function. These are quite simple concepts and you can score very well in the examination because there is no difficulty in solving the problems or understanding the concepts. So, let us start today. Continuity of a function. Continuity is very much related to limits. You know, this is a graph and suppose this is x at any point x a. First we will talk about continuity of a function at a point a. So, suppose this is f x you can see while discussing the limits, we discussed that just before point A, we will take the how the value of this function changes as we approach towards A from left. This we call limit A minus f x. So, the value to which it is arriving is called its left hand limit, because we are approaching from left hand. Again, when we approach from the right hand, from this side, we are approaching x from this side, that is x plus. Actually, we should say it a plus. This is a plus, this is a minus. So, we approached from this side and found out the left hand limit. Then we discussed about right hand limit, that we approach from the right side, that is a plus. So, we are approaching from the value of x more than a. Now, we are approaching towards a. So, what will the value of function f x? This is a concept, you do not need to worry, and there is a method how to solve the problems on these. So, this value of f x, this limit will be called right hand limit. Here you can see that the value of LHL is not equal to RHL, because this point and this points are different values. This is LHL and this is RHL. If these are not equal, we say that limit does not exist. limit doesn't exist. Now, let us see another case. This is x axis, this is y axis, and let us take the value of f x at x is equal to a. So, suppose this is the function and let us say this is a minus, this is a plus. We are approaching here from this side and we are approaching here from this side. But what is the value at point A, f a? This is not defined. Then you see limit x tends to a minus, we are approaching from left, f x, say this is L1, this is L1, and limit x tends to a plus approaching from this side, this limit is L2. You can see that L2 is also here. So, L1, L2 are at the same point. So, RHL is equal to LHL. So, in this case the limit exists, but FA does not exist. FA not defined. So, in this case this point is excluded from the range. So, this is not continuous. This is not continuous. So, in a simple way we can say that if you are taking pencil along the line and if you do not have to pick up your pencil from continuing it, then we call it a continuous function. But here this point is not defined. So, here you have to pick your pencil up. So, this is not continuous although the limit exists. So, this is the simple definition of the continuity. Now, let us take another case. It is very simple but quite important concept. Red use, ठीक है. So, let us take x, y, and at x is equal to a, this is a minus, this is a plus, this is a straight line, say y is equal to 2x plus 3, the value of left hand limit say let us take a is equal to 2. So, 2 minus will be f x x tends to 2 minus. So, it means that when we approach from this side, what will be the value of y f x? This will be equal to 2 into 2 plus 3. So, it will be equal to 7, because as we approach from the left side, as we approach towards a is equal to 2, this value will approach from this side 7. Now, we have learned this in limit. If x tends to 2 plus, it means that x is approaching from this side, a is equal to more than 2, then f x will be value of will be again 2 into 2 plus 3 is equal to 7. So, it will approach from this side and it will again reach from this point, which is 7. So, this is also equal to 7. If I find out the value of function at a, that is a is equal to 2, it will be 2 into 2 plus 3 is equal to 7. So, this is the case where all the three are matching, that is LHL is equal to RHL is equal to FA. So, this function is continuous. So, let us now come to its formal definition. Definition is also quite simple. It states the same thing, that at any point a, f x is continuous if and only if the left hand limit is equal to right hand limit is equal to the value of function at point A. So, how do we define it? You need not remember this, you should only learn the concept that a function is continuous if and only if we, in short, we write it as IFF, if. So, limit x tends to a minus fx, that is left hand limit, is equal to limit x tends to a plus, we approach from the right side, which is equal to f a. So, only in this condition only we will call that function is continuous. Okay. Let us take example. Suppose fx is given mod x minus 3 and we have to check continuity at x is equal to 3. Okay. So, let us take the left hand limit, that is limit x tends to 3 minus mod of x minus 3 will be equal to, since we are approaching from left side, so x will be less than 3. So, 3 minus 3 will be negative, some negative, but it will be nearing to 0. Okay. So, it will again become, because mod is there, so it will become positive. So, it will become 0. Similarly, right hand limit, you can do it by first principle also. Limit 3 plus mod x minus 3, it is some positive value, but nearing to 0. So, it will also become 0, and if we take f x is equal to 3, so it will be equal to mod 3 minus 3, which will be equal to 0. So, you can see that left hand limit, right hand limit and the value of f at 3, all three have the same value, that is 0. So, this is a continuous function. Now, let us take some more examples so that the concept of continuity will be more clear to you. Say x upon mod x, f x is equal to x upon mod x. So, we will take LHL, left hand limit, x tends to, and at x is equal to 0. So, x tends to 0 minus x upon mod x since x is tending from left side. So, it will be less than 0. So, it will have some negative value, and this negative value will change to plus because it is mod. So, it will be minus x divided by x. So, this will cancel out. So, this is equal to minus 1. If we take it from first principle, we can say that let us take x is equal to 0 minus h, okay, where h is a small quantity. So, this will become this limit h tends to 0 plus, because it will be positive quantity h, will be x is 0 minus h upon mod of 0 minus h. So, h tends to 0 plus, it will be minus h upon h. So, this will be cancelled out, this is minus 1. Okay. If we take the right hand limit, what result will come? Limit x tends to 0 plus. So, we are coming from the right side. So, in that case x divided by mod x, it will be slightly more than 0. So, its value will be x upon x, which will be positive quantity. So, it will be equal to 1. So, here you can see that left hand limit is minus 1. You can see the left hand limit is coming out to be minus 1, whereas the right hand limit is coming out to be plus 1. This is plus and this is minus. These are not equal. So, in this case the limit does not exist. So, there is no continuity. No limit, no continuity. So, function we can define as continuous if for a particular interval, say this is a real number line, this is A. So, suppose interval is given A and B. If within this interval for every point, if the function is continuous, limit exists and function is continuous, then we call that the function is continuous throughout this interval. Function fails to be continuous in two conditions, either fails in two conditions, either LHL left hand limit and RHL are not equal, or LHL if they are equal, then LHL and RHL are not equal to FA. So, in these two conditions, we say that function is not continuous. But there are examples. Let us take few more examples. Say fx is equal to sin x upon x, but it is not defined at x is equal to 0. When x is not equal to 0, but when x is equal to 0, it is defined as 1. Let us see this function. Its LHL is equal to limit x tends to 0 sin x upon x. Now, this is equal to 1, and RHL limit x tends to 0 plus, because it is not defined at x is equal to 0, but it is defined just before the x and just after the x, just after the 0 and just before the 0. Again its value will be equal to 1, and if we take f0, this value is at x is equal to 0, its value is given 1, so it is equal to 1. So, all these three values are coinciding, so it is continuous function. You are aware of the sinusoidal function. In fact, at every point of x, a sine or cosine function is continuous, and in your energy courses you will come across many such instances, but this is not purely sinusoidal, it is sin x upon x upon x. So, this function is like this. then it will start decreasing. You see, this is, it will be maximum at 0, its value will be 1. So, as it is going farther and farther from x, the peak is decreasing, but the function, the shape of the function will remain same, and it, as it is going to minus infinity this side, the value of x, again its shape is decreasing. So, this is the graph of this function. Now, let us take a function, another example, f x is equal to 1 by x. So, again it is not defined at x is equal to, when x is not equal to 0. If you draw its graph, it will be like this. So, it is not defined at x is equal to 0. Why? Because its value is varying from plus infinity to minus infinity, 1 by x. So, if you put value 0, the function f x will become infinity, and you do not know whether minus infinity or plus infinity. So, this is not defined at x equal to 0. So, it is not continuous, it is discontinuous at x is equal to 0. But for all other points, this is a continuous function. If you take any other point in the curve, this is continuous. Continuous at all other points when x is not equal to 0. So, only at x is equal to 0 if you exclude this point, otherwise this function is continuous. Let us take few examples. Suppose it is given that function is continuous and you have to find out the values of some constant function. How will you do that? Question is, find relation between A and B given function is continuous at x is equal to 0. Now, what is the function? Function is defined as two x minus a if x is greater than equal to 0 and it is equal to a x plus b plus 3 if x is less than 0. So, let us take out left hand limit, that is equal to limit x tends to 0 minus. So, if x is 0 minus, it means less than 0. So, this case will be applicable. So, this will be a x plus b plus 3. So, putting x is equal to 0, its value will be b plus 3. Now, if I take right hand limit x tend to 0 plus, so this is more than 0. So, the first case will be applicable. So, it will be equal to 2x minus a. So, putting x is equal to 0, it will be equal to minus a. And what will the value of function f0, putting x is equal to 0, since greater than equal to 0, this case will be applicable. So, this will be equal to minus a. So, since it is given that function is continuous, so its LHL will be equal to RHL, which is equal to FA. So, LHL is equal to b plus 3 and will be equal to minus a. So, this gives the relation that a plus b plus 3 is equal to 0. So, this is the relation which will have to satisfy for making the function continuous. So, friends, it is clear to you that how the function continuity or function is checked at a point, and if within a range the function is continuous, then we call, if within a range function is continuous at all the points, then we call it that function is continuous for the entire range. And if suppose there are two functions f x and g x and both are continuous in an interval a b, then the simple algebra you should remember. I will just write it here. That in that case, if f x and g x are continuous, then f x plus g x at x is equal to a will be continuous. Similarly, f x minus Gx will be continuous. Fx dot Gx multiplication will be continuous, and Fx divided by Gx will also be continuous if Gx is not equal to 0 at x is equal to a. So, these are the conditions. So, we have covered the continuity of function. Now, next time we will see a few more examples on limits and continuity, and I will clearing your doubts. If you have any question, you can send it or ask it in the next class. Thank you very much.